Hello there, this is Alan Dave de la Cruz, and in this video, we will be discussing about the measures of relative position or quantiles for group data. To define measure of position, it is a method by which the position that a particular data value has within a given data set can be identified. As with other types of measures, there is more than one approach to define such a measure. Measure of position give us a way to see where a certain data point or value falls in a sample or distribution. A measure can tell us whether a value is about the average or whether it is unusually high or low. Measures of position are used for quantitative data that falls on some numerical scale. Sometimes, measures can be applied to ordinal variables, those variables that have an order. Particularly, there are three measures of position, namely percentiles, deciles, and quartiles. The quartiles are three values that divide the data. For the Q sub 1 or first quartile, also called the lower quartile, 25% of the distribution falls below and 75% falls above the value on the Q sub 1. For the Q sub 2 or second quartile, also called the median, 50% of the distribution falls below and the other 50% falls above the value on the Q sub 2. For the Q sub 3 or third quartile, also called upper quartile, 75% of the distribution is less than the value on the Q sub 3, while the remaining 25% is greater. Now let us have the formula for the quartile of group data. So we have Q sub k equals to LB plus the quantity of Kn over 4 minus CFB over FQK times I, where LB is the lower boundary of the QK class, N is the total frequency, CFB is the cumulative frequency of the class before the QK class, FQK is the frequency of the QK class, I is the size of class interval, K is equal to N quartile, where N is equal to 1, 2, and 3. Now we have some of the examples of group data. For our first problem, we have the table shows the scores of students in math quiz. Find the Q sub 1 class. Here we have our table. Our first column shows the scores of students. The lowest scores that we have is 21 and the highest score is 50. Each row has the same interval, and our interval for this one is 5. The next column is the frequency, or on how frequent the score occurred. For example, we have 21 to 25. The frequency for that is 6. That means that there are 6 students who got that score within that range. On our frequency, we have 4, 8, 11, 9, 12, and 6. Now on our frequency, the total number of it is 50 as what it is shown below, or that N is equal to 50. The next column of our table is called the lower boundary. For us to get the value of our lower boundary, we would just simply subtract the number by 0.5. For our first value, we have subtracted 46 to 0.5. This gives us 45.5. For the next value is that we will subtract 41 to 0.5, that also give us 40.5. And for the rest of it, we will only subtract it to 0.5. Now, the next column of our table is the CFB, or the cumulative frequency below. For us to get the first value of our cumulative frequency below, we will just only simply copy that frequency on the lowest score. So the frequency of the lowest score was 6. On this time, we will just copy it to have our first value of our CFB. Next, for us to get another value, we will just simply add it to the next frequency. So our first cumulative frequency is 6. Now we will just simply add it to the frequency next to it, which is 12, which will give us the value of 18. Now 18 also added by 9 will give us 27. 27 added by 11 will give us 38, and so forth. And that is how we get the CFB, or the cumulative frequency below. Now, here is our solution. So first we're going to get the value of it. And for the first step, we will going to get the value of Kn over 4. To get the value of Kn over 4 is that we will solve it first by using Qk is equal to Kn over 4. Now substitute the K. Since we are looking for the Q sub 1 set, we will substitute K to 1. So Q1 is equal to 1 multiplied by 50 over 4. Q1 is equal to 50 over 4. So 50 divided by 4, and that will give us Q1 is equal to 12.5. Now that is the value of our Kn over 4. After finding our Kn over 4, we will now locate the answer, which is 12.5 on our table. Now our 12.5 is located between 6 and 18. Since 6 is less than 12.5, we will go up in 18 to place 12.5 as included within that class. Now we will encircle it and label it as our Q1 class. After that, we will find the rest of the value of our formula. So by looking at the encircled class, our LB is 25.5, CFB, which is 6, our I, or interval, is 5, and our FQK is 12, or the frequency. And now, we are going to solve for our Q sub 1. For our solution, QK is equals to LB plus Kn over 4 minus CFB over FQK times I. Substitute Q sub 1 is equals to 25.5 plus 12.5 minus 6 over 12 times 5. We will solve first the numbers within the parentheses. So 12.5 minus 6, we will get 6.5. And then after that, we will divide 6.5 by 12. So Q sub 1 is equal to 25.5 plus 0.54 times 5. Next is that we will multiply 0.54 to 5. Q sub 1 is equal to 25.5 plus 2.70. Adding both numbers will give us the result of our Q sub 1. Now, our Q sub 1 is equal to 28.2. Now to interpret our data is that therefore 25% of the students have scored less than or equal to 28.2. Now, let us proceed to our second problem. The table shows the ages of teachers in XYZ College. Find the Q sub 1, Q sub 2, and Q sub 3 class. Here, we have the table, and that first column is that we have the ages of the teachers. The lowest is 24, and the highest is 65. So each row has the same interval. For this one, the interval of this problem, or the interval of their ages per row, is 7. On the next column is that we have our frequency. The total of our frequency for the ages of teachers is that we have 50, which means there are 50 teachers. On our next column is that we have LB, or lower boundary. To get our first lower boundary, we will simply subtract 0.5. For example, 59 subtracted by 0.5 will give us the first value of 58.5. Next, below 59 is 52. So 52 subtracted by 0.5 is 51.5. 42 subtracted by 0.5 is 44.5. 38 subtracted by 0.5 is 37.5. 31 subtracted by 0.5 is 30.5. 24 subtracted by 0.5 is 23.5. And that is how we get our lower boundary for this table. Next column is that we have the CFB, or this is called the cumulative frequency below. To get the first value of our CFB is that we would simply copy the first or the lowest frequency of H. So on our frequency, we can say that the frequency of that lowest H is 11. Now, we would just simply copy 11 as our first value of our CFB. Now, to get the next value of our CFB is that we would simply add CFB to the next frequency. So the next frequency above it is 9. Now 11 added by 9 is 20. Next is that we will do the same thing to 20 by adding it to the next frequency. So 20 added by 14 is 34, and 34 added by 2 is 36. 36 added by 11 is 47, and 47 added by 3 will give us 50. Remember that the last CFB should be the same as the total frequency. Our last CFB is 50, and our total frequency is also in a total of 50. After we have completed finding our data, we will now find the value of our formula. So first, we will find the value of Kn over 4. The formula in getting Kn over 4 is Qk is equal to Kn over 4. We will then substitute K. Since we are looking for the Q sub 1, we will put 1 as our K. So Q1 or Q sub 1 is equal to 1 times 50 over 4. Q sub 1 is equal to 50 over 4. Now, 50 divided by 4 will give us 12.5. So our Q1 is equal to 12.5. After that, we will locate 12.5 within our table. So our 12.5 is in between 11 and 20. We can't locate, or we can't put 12.5 in 11 because it is less than the value. So we will place 12.5 in belong to the 20. Now we will encircle this class and label it as the Q1 class. This time, we will find the value of the rest of the formula. So LB is equal to 30.5, CFB is equal to 11, I or the interval is equal to 7, and FQK is equal to 9. After that, we will now solve for our Q sub 1 class. First is our formula, which is the QK is equal to LB plus Kn over 4 minus CFB over FQK times I. Substitute Q sub 1 is equal to 30.5 plus 12.5 minus 11 divided by 9 times 7. So first, we will solve for the numbers within the parentheses. So 12.5 minus 11 is equal to 1.5. Now, the next step is that we will divide 1.5 by 9. So Q sub 1 is equal to 30.5 plus 0.16 times 7. Now, we will divide 1.5 by 9. So 1.5 divided by 9 is 0.16. So Q sub 1 is equal to 30.5 plus 0.16 times 7. Multiply 0.16 by 7. This will give us 1.17. So Q sub 1 is equal to 30.5 plus 1.17. Now we will going to add 30.5 plus 1.17. And this will give us the answer of our Q sub 1, which is 31.67. Now, to interpret our sub 1 class is that therefore 25 of the teacher's age is less than or equal to 31.67. After Q sub 1 class is now we will going to find for our Q sub 2 class. To find the value of our Q sub 2 class is that again we will solve for our Kn over 4, but this time we will change the value of our K to 2 because we are now on the Q sub 2 class. So Q sub K is equal to Kn over 4, substitute to 2, Q sub 2 is equal to 2 times 50 over 4. So 2 times 50 is 100. Q2 or Q sub 2 is equal to 100 over 4. Divide 100 by 4. Q sub 2 is equal to 25. Now, we will locate 25 in our table. In our table, 25 is located between 20 and 34. Instead, we will put 25 within 34. Now, this row will be now our Q sub 2 class. And this is where we're going to find our value for our formula. Now the value of our LB is 37.5, CFB is 20, I or the interval is 7, and FQK is 14. After that, we will now solve for our Q sub 2 class. For our formula, Q sub K is equal to LB plus Kn over 4 minus CFB over FQK times I. Substitute Q2 or Q sub 2 is equal to 37.5 plus 25 minus 20 over 14 times 7. First is that we will going to solve for the numbers within the parentheses. So 25 minus 20 will give us 5. Q sub 2 is equal to 37.5 plus 5 over 14 times 7. Now we were going to divide 5 to 14. So 5 divided by 14 will give us 0.37. Q sub 2 is equal to 37.5 plus 0.36 times 7. Now multiply 0.36 by 7. Q sub 2 is equal to 37.5 plus 2.52. For this time, we were going to add 37.5 plus 2.52. Now, this will give us the answer for our Q sub 2, which is 40.02. To interpret our answer is that therefore 50% of the teacher's age is less than or equal to 40.02. After finding our Q sub 2 class is now, we will then proceed to finding our Q sub 3 class. Again, we will start by finding the value of our Kn over 4. This time, we will substitute the K to 3 as we are looking for the Q sub 3 class. Now, Q sub K is equal to Kn over 4. Substitute, Q sub 3 is equal to 3 times 50 over 4. So, 50 times 3 is 150. Q sub 3 is equal to 150 over 4. 150 divided by 4 will give us 37.5. Now, the value of our Kn over 4 is 37.5. After that, we will now locate 37.5 within our table. We will then find the rest of the value of our formula. So, LB is equal to 51.5, CFP is equal to 36, I or the interval is equal to 7, and FQK is equal to 11. Now, we will then proceed in finding our Q sub 3 class. So first, we will put our formula. Q sub K is equal to LB plus Kn over 4 minus CFB divided by FQK times I or the interval. Substitute. Q sub 3 is equal to 51.5 plus 37.5 minus 36 divided by 11 times 7. First is that we will going to solve for the numbers within the parentheses. So 37.5 minus 36 is 1.5. So Q sub 3 is equal to 51.5 plus 1.5 over 11 times 7. Again, we will solve 1.5. This time, we will going to divide 1.5 by 11. This will give us 0.14. So, Q sub 3 is equal to 51.5 plus 0.14 times 7. This time, we will going to multiply 0.14 by 7. And this will give us 0.98. Now, Q sub 3 is equal to 51.5 plus 0.98. For this time, we will going to add 51.5 plus 0.98. So Q sub 3 is equal to 52.48. To interpret our answer is that therefore 75% of the teacher's age is less than or equal to 52.48. And here is our last problem. Harry recorded the number of rooms that can accommodate a certain number of guests. Find the Q sub 1 class. Here is our table. The first column shows the number of guests. So the lowest number of our guests is within 1 to 10 and the highest is within 41 to 50. In this column, they have the same interval. On the next column is we have the frequency or the number of rooms. For example, is the guest from 41 to 50 is that there are 3 rooms that can accommodate them. For guests of 31 to 40, there are 5 rooms to accommodate them. 21 to 30, there are 9 rooms. For 11 to 20 guests, there are 7 rooms to accommodate them. And for 1 to 10 guests, there are 6 rooms to accommodate them. The total frequency for this is 50, or the n is equal to 50. Next column is we have our LB, or our lower boundary. Again, to get our lower boundary is that we will only subtract 0.5 to the number. For example, our first value is that we will subtract 41 to 0.5. This will give us 40.5. Next is 31 subtracted by 0.5 is 30.5. 21 is subtracted by 0.5 is 20.5. 11 subtracted by 0.5 is 10.5, and 1 subtracted by 0.5 is 0.5. Next to this is the column for our CFB, or our cumulative frequency below. To get the first value of our CFB is that we will only simply copy the frequency from the lowest value of guest. That frequency is 6. Now, we will copy 6 as our first value of our CFB. To get the next value of our CFB is that we will add to the next frequency, which is 7. Now, 6 added by 7 is equal to 13. 13 added by 9 is 22. 22 added by 5 is 27. And 27 added by 3 is 30. To get the value of our Q sub 1 class is that we will first solve for the Kn over 4. So the formula is Qk is equal to Kn over 4. Substitute. Q sub 1 is equal to, or Q1 is equal to 1 times 30 over 4. Q1 is equal to 30 divided by 4. 30 divided by 4 is 7.5. So our Q1 is equal to 7.5. Now, we will locate 7.5. Since 7.5 is between 6 and 13, we will then locate 7.5 within 13, since 6 is less than the value of 7. Now, we will encircle this row and label this as our Q sub 1 class. We will now get the value of our formula. So LB is equal to 10.5, CFB is equal to 6, and I is equal to 10, and FQK is equal to 30. Now for our formula, QK is equal to LB plus Kn over 4 minus CFB divided by FQK times I. Substitute. Q sub 1 is equal to 10.5 plus 7.5 minus 6 divided by 30 times 10. Solve for the numbers within the parentheses. So 7.5 minus 6 is equal to 1.5. Q sub 1 is equal to 10.5 plus 1.5 divided by 30 times 10. So 1.5 divided by 30 is 0.05. Q sub 1 is equal to 10 plus 5 plus 0.05 times 10. Now 0.05 multiplied by 10 is 0.5. So Q sub 1 is equal to 10.5 plus 0.5. This time, we will add both numbers. So 10.5 plus 0.5 will give us Q sub 1 is equal to 11. To interpret our answer is that therefore, 25% of the rooms can accommodate less than or equal to 11 guests. And that's the end of our video. Thank you for watching.